Hello, my name is Chicho Robert. Welcome to Digital Classroom Series. This is the chemistry class. Unlike the previous tutorials, today we want to learn differently. We are going to quickly navigate over College.com website and study from there. So let's get started. In your Google search, type in Over College. Search. In this we shall choose this first option, then we shall be redirected to the Over College website. Now in this case, because this is the chemistry class, you can say there are a lot of options to choose from. Because this is the chemistry class, let's choose this first option. Okay, so we're going to study about oxygen properties. In this course, if you don't have an account or you are not registered, please log in with your username and password to access this course. So let's get started. In the previous tutorial, we studied about oxygen and its preparation. Today, let's continue further to investigate the physical and chemical properties of oxygen. So let's start with the physical properties. Oxygen is a colorless, odorless, and tasteless gas. Oxygen is also neutral to litmus paper. Oxygen is also slightly soluble in cold water. Oxygen is also slightly denser than air. A physical property is a characteristic of matter that is not associated with the change in the chemical composition. Familiar examples of physical properties include those which we have mentioned earlier, like the density, color, odor, and solubility. These properties are observed without changing the physical state of a substance. In this case, we are referring to oxygen gas. Now let's proceed to the chemical properties of oxygen. A chemical property is associated with a change in the chemical composition of a substance. For example, change of matter into another form. For example, the toxicity, acidity, ability to burn, and also reactivity. Let's discuss some of these chemical properties. Oxygen supports the burning of both metals and nonmetals. Let's start with the metals. Metals such as magnesium, sodium, and calcium burn in oxygen to form basic oxides. We can demonstrate this in this way. A metal reacts with oxygen to form a metal oxide. Let's start with magnesium. Magnesium burns in oxygen with a very bright white flame, forming white ash of magnesium oxide. We can demonstrate this by using a magnesium ribbon. Magnesium is a metal, and as you can see, it is shiny, malleable or bendable, and conducts heat. So what we are going to do, we are going to react this magnesium ribbon with oxygen. It requires some energy to enable magnesium to react with oxygen. So it burns with a very bright light, and a white ash is formed. This white ash is magnesium oxide. Let's look at the equation of reaction between magnesium and oxygen. Magnesium reacts with oxygen gas to form magnesium oxide. As you can see, we have two oxygen atoms on the left hand side and only one oxygen atom on the right hand side. So we can balance this by adding 2 in front of magnesium on the right hand side. So now they become 2 magnesium atoms. We can go on to further add a 2 in front of magnesium to balance this equation. This equation is now balanced. However, this is oxygen gas. Magnesium further reacts with water to form magnesium hydroxide. Now let's proceed to sodium. Sodium burns with a brilliant yellow flame to form a yellow solid of sodium peroxide. Sodium is a silvery gray solid. Sodium burns with a bright yellow flame to form sodium peroxide in excess oxygen. In a limited amount of oxygen, sodium oxide is formed. Actually, sodium oxide is formed as white fumes, as you can see. So what is the equation for this reaction? Sodium reacts with oxygen gas to form sodium peroxide. Now let's balance this equation. As you can see, we have 1 sodium atom on the left hand side and 2 sodium atoms on the right hand side. We can balance this by adding 2 in front of sodium to balance this equation. So in limited amount of oxygen, sodium burns to form a white solid of sodium oxide. So how can we balance this equation? Sodium reacts with oxygen to form sodium oxide. We can balance this by adding 2 in front of sodium to balance. So we have to balance oxygen. Let's proceed by adding 2 here. Now we notice that once we add 2, sodium now becomes 4. So we can now balance by adding 4 in front of sodium. Now the equation balances. Also, sodium oxide dissolves in water to form sodium hydroxide. In this equation, we have 2 sodium atoms on the left hand side and 1 sodium atom on the right hand side. We also have 2 hydrogen atoms on the left hand side and 1 hydrogen atom on the right hand side. So what we do in order to balance sodium, we add 2 in front of sodium. So now the equation balances. Let's proceed to iron. Iron burns in oxygen with bright sparks to form a blue-black beads of tri-iron tetraoxide. Iron is a brown solid. Iron reacts with oxygen with very bright sparks to form various iron oxides, that is iron 2 and iron 3 oxides, depending on the nature or conditions of the reaction. In this case, tri-iron tetraoxide is formed. Notice that tri-iron tetraoxide is a combination of iron 2 and iron 3 oxide. Let's look at the equation of the reaction. Iron reacts with oxygen to form tri-iron tetraoxide. Now, what we can see here, we see that we have 3 iron atoms on the right hand side and 1 iron atom on the left hand side. We have 2 oxygen atoms on the left hand side and 4 oxygen atoms on the right hand side. So let's start with iron. Because we have 3 iron atoms, we can balance iron by adding 3 in front of iron. However, oxygen are now 2 on the left hand side and 4 on the right hand side. We can balance oxygen now by adding 2 in front of oxygen by using multiples. The trick we are using here is to increase the number of atoms which are less so that they balance with the other one which are more, as we can see for the case of iron and oxygen. We consider those ones which are less. Calcium. Calcium burns with oxygen with a very bright red flame to form white calcium oxide. In this case, calcium reacts with oxygen to form calcium oxide. So you can balance oxygen by adding a 2 in front of calcium. So now they become 2 oxygen atoms. Now calcium atoms becomes 2. So you can further go on to balance calcium by adding 2 in front of calcium on the left hand side. So the equation now balances. Now let's proceed to nonmetals. Nonmetals such as carbon, sulfur, phosphorus burn in oxygen to form acidic oxides. Carbon burns with an orange flame and makes bright sparks. It forms carbon dioxide, which turns calcium hydroxide milky. Carbon dioxide dissolves in water to form carbonic acid, which turns blue litmus paper red. Carbon occurs in a variety of forms like coal, soot, charcoal, and diamond. Carbon burns with an orange flame to form carbon dioxide gas. Carbon dioxide dissolves in water to form carbonic acid. Burning or combustion of carbon gave rise to the Industrial Revolution. Now let's look at the equation for this reaction. We can say carbon, which is a solid, reacts with oxygen gas to form carbon dioxide. As you can see, we have 1 carbon atom and 2 oxygen atoms on both sides. So this equation is balanced. Furthermore, carbon dioxide dissolves in water to form carbonic acid. In this case, it is a reversible reaction. So we represent it by 2 double arrows. Let's proceed to sulfur. Sulfur burns with a bright blue flame to form cloudy fumes with a choking smell. The gas formed is sulfur dioxide, which dissolves in water to form sulfurous acid, which turns blue litmus paper red. Sulfur is a yellow nonmetal. We are going to burn it in oxygen. When a small amount of sulfur powder is placed on a defragmented spoon, it's first heated on the flame of the Bunsen burner and then placed in the gas jar of oxygen. Sulfur burns with a blue flame to produce a choking gas called sulfur dioxide. At the bottom, there is a little amount of water. Thus, sulfur dioxide reacts with water to form sulfurous acid. This acid turns blue litmus paper red. Recall that sulfurous acid also forms part of acid rain. Now, let's look at the equation for this reaction. Sulfur reacts with oxygen to form sulfur dioxide. This equation, as you can see, is also balanced. Furthermore, this sulfur dioxide dissolves in water to form sulfurous acid. There is a difference between sulfurous acid and sulfuric acid. Finally, let's look at phosphorus. Phosphorus burns with a very bright yellow flame, forming dense white fumes. Phosphorus is a white solid. When a piece of white phosphorus is dried and placed on a glass deflagrated spoon and then lowered in a flask of oxygen, this element soon ignites and burns vigorously with a very bright yellow flame to form phosphorus pentaoxide. This is often called the phosphorus sun. Actually, because of this amount of light, phosphorus is used in flares and fireworks to produce that bright light. Now let's finally look at the equation of the reaction. Phosphorus, which is a solid, burns in oxygen to form phosphorus pentaoxide. You can see we have 2 oxygen atoms on the left hand side and 10 oxygen atoms on the right hand side. So what do we do to balance oxygen? You can balance oxygen by adding 5 in front of oxygen, so that the equation balances. In this case, we have 2 oxygen atoms on the left hand side and 6 oxygen atoms on the right hand side. So we can get a mouthful which can give us 6, so that we balance this oxygen atom. So in this case we shall add 3 to make 6. So this equation is now balanced. It's really very important to know how to balance chemical equations. So I believe we've got some ideas about the physical and chemical properties of oxygen in this tutorial. So for more tutorials, you can visit this website, or if there is any query or question, you can reach us here on the live support and we'll help you out. Thank you for watching.